In this video, I will show you how to solve an optimization problem using calculus. So let's read the question. We have a function that gives us the number of cars that we can rent at price P. And the domain here is between 50 and 200. So let's find out what is that we're trying to maximize or minimize here. So the question clearly states that we are maximizing the revenue, so we need to focus on finding the revenue function. So the revenue function, so how does the car rental company creates the revenue? By renting the cars, right? So the revenue is a function of, let's find out. So to make a revenue, a company rents out the car, and for each car it gets P amount of money. So the total amount of money will be, or can be computed by multiplying NP, the number of cars rented at price P, by the price P. So we have control of price P. Therefore, the revenue function depends on our choice of the price to charge the for the car rental. And plugging in the expression for N of P gives us a function. If we distribute everything, this is a function for the revenue of this company. So if we want to maximize the revenue, and we're only considering this function on this domain, and if we want to maximize the revenue, that means we have to find the absolute maximum of this function on this closed interval. And to do that, we have to differentiate the function, set it equal to 0, or find where it doesn't exist, and then evaluate the function at all the points, and the largest value will be the absolute maximum. So let's go ahead and find the derivative of this function. It is negative 10p plus 1000. Since this derivative is a linear function, it is always defined, so there are no values where it doesn't exist. So we only looking for the points where it equals to 0. So let's solve this equation, and we can find out that p is equal to 100. However, we can't conclude right away that this is the price that we have to charge. We have to compare the outcome of the function at this point with the outcome of the function on the closed interval, at the endpoints of the closed interval, because it is totally possible that we can maximize the revenue by just trying to maximize the number of cars that we rent at $50 per car. So let's go ahead and find R of 50, or actually, instead of evaluating the function, we can do the sign chart of the derivative, right? So when p is greater than 100, then the derivative is negative, and when p is less than 100, the derivative is positive. So with this knowledge, we don't have to now evaluate the function at 50 and 200, because clearly we have a relative and absolute max at 100, right? So that means that we, or they, should charge $100 to maximize the revenue.